Hi Stats class, it's Miss O'Neill. Today's focus is going to be on proportional word problems. Our date is May 12th, 2020. So, last week you spent time focusing on a proportion, which remember is two fractions set equal to each other. Our biggest idea was how do I go and find the missing piece that would make one fraction equal to the other fraction. We're still going to involve that same kind of concept here, but the difference is all of your examples are going to be missing the proportion you're supposed to be solving. So our new goal is to first be capable of setting up the proportion that we are then going to solve. There's kind of a issue though when you first are working with a word problem. There's going to be information that is said to you within the word problem that you're going to have to organize in a very specific way. When we're talking about proportions, they can be used to solve word problems in which there is a constant rate. And remember, we had said constant rate is a fancy way of saying something that is going to continue to repeat. It's what you're changing by. So, in this situation, it's very important to stay consistent when setting up your proportion. What that means is if you set up your fraction in one specific way, that other fraction that you're trying to make equal has to also be in that same order. So let's look at these two different kinds of proportions. And we're going to try to figure out which of the following equations is a valid proportion, meaning which one is the better option, the one that's going to work for us. Option 1 has miles per hours equal to hours per miles. Option 2, miles per hours equals miles per hour. If you had to pick option 1 or option 2, which one is a valid proportion? Option 2. We can truly say this fraction equals that fraction, even down to the order they are matching in the way that they are set up. This is what we're always going to aim for. It doesn't matter what you put on top, but if you set up the first fraction in this way, you better have the second fraction matching that same order. So let's try to put it to some practice. Our directions tell us to solve each word problem using a proportion. Round to the nearest tenth or cent when necessary. Number 1 tells us that Pete drove 224 miles in 4 hours on Saturday. If he drives at the same rate on Sunday, how long will it take him to drive 490 miles? So, we talked in class a lot about this idea of what is important. I know some of you are going to look at your problem and say these 3 numbers matter. But it's not just the numbers. Believe it or not, math is just as much as important as the reading of the problem. That's 224 miles in 4 hours. And this 490 represents miles as well. So if we know our goal is to set up a fraction equal to a fraction, looking at your information, we have our first fraction written right here. It is in one sentence. It ends with a period. So in this first sentence, it tells us that Pete drove 224 miles in 4 hours. So it's kind of up to you in which one you would prefer to write first on your fraction. I always like to write what I see first. 224 miles in means we're getting ready to switch from the top to the bottom, 4 hours. So, if we take a look, our first fraction has miles on top of the hours, which means this fraction is going to have miles on top of the hours. If you've already used these details, you can't use them again. So we look back at our story. The only other number in this situation is 490, and that represented miles. So we are going to find the word miles and put 490 with it. But that leaves us the question, what is supposed to go here? If we look at the question, a question mark tells us what we're trying to focus in on, the whole purpose. It told us how long. How long is asking you to figure out time. How long is this class going to take? How long is it till the end of the school year? All of those kinds of questions are saying how long, meaning a time frame. If I'm looking, I'm being asked how long is it going to take, how many hours, to drive 490 miles. We don't know it. So if we don't know, we put a letter X. And this will remind me that X is standing for hours. Once I've got my proportion, we're going right back to what we were doing before, cross multiplication. If we have 224, it's going to follow across the equal sign to X. And we know 224 times X is 224X. Put your equal sign. And then we have 4 times 490. 4 times 490 in your calculators is 1,960. We know we aren't done because I can't say X equals a number. This says 224X equals that. So we have to ask ourselves, how do I get this equation to say X equals? What would I do with the 224? Correct. Divide both sides by the number you want to get rid of, 224. Those would cross, and I get X equals 8.75 hours. I know it's hours because if I look back at my fraction, the letter X was next to the word hours. Because we're now tying in a story, your final answer has to have a unit attached to it. What is it actually representing in this story? In this case, it represents the time, hours. So this part right here is nothing new. This is what you practiced 2 weeks ago and you had a quiz on last week. The thing that's changing is that instead of me giving you the proportion right away, I'm trapping it within inside of a word prompt. You know every single time it's going to be a fraction equal to a fraction. What we need to be able to do is to find the details within the story to be able to set this up in a way that would allow us to be able to solve the proportion. There's always going to be one number missing, and that number is going to depend on what the question asks. So let's take a look at number 2. Approximately 4 out of 5 students in Mrs. Haynes' 7th grade math class have cell phones. If there are 365 students in the 7th grade, how many would you expect to have a cell phone? So, a couple of things here. This is one of those problems where you are being told information that is not necessary, okay? Things that are necessary. 4 out of 5 students have a cell phone. There are 365 students in all of 7th grade. And my question mark wants to know how many would you expect to have a cell phone? Notice how I never highlighted the number 7. This just tells us about the 7th grade. It has nothing to do with the cell phones or the number of students within this grade level. It's just focusing in on one specific grade level. We don't actually need that to solve our problem. So if we're looking at the first detail, this is an example just like the one previously, where it's giving us one entire fraction in one sentence. 4 out of 5. 4 out of 5. And if we remember correctly, this is 4 out of 5 students in Mrs. Haynes' grade, 7th grade math class, that have cell phones. So this is where they have cell phone. Okay? In this case, this bottom one represents the total. So if I have people who have cell phones on top and the total on the bottom, I know we're going to have a total over here. And we're going to have cell phone on top. Your fraction has to stay consistent for it to be remaining equal. If we look at our next detail, 365 students in the 7th grade. Did this 365 have anything to do with having a cell phone? No, it's just representing the 7th grade. So we're going to put that on the bottom. On top is the number of kids in the 7th grade that have a cell phone. If I keep rereading, they never mention that because it wants you to figure it out. So there goes our X. You can use any letter that you want. You could have used a K, you could have used a C for cell phone, you could have used an H. It doesn't make a difference. The big thing here is that you are telling yourself that there is something we are missing, something that is unknown, and we're trying to figure that out. So once we have our proportion set up, cross multiply, step number 1. 5 times X, 4 times 365. Finishing off this proportion, we would divide both sides by 5. That lets the 5's cancel, and I get X equals 1,460 divided by 5 is 292. Now, if we're looking back, this is 292 that have a cell phone, and this whole story was about students. Okay, so we have 292 students that have a cell phone based off of the proportion that we solved. All right, let's move on down to questions 3 and 4. So again, big thing here is you're trying to set up a proportion, meaning a fraction equal to another fraction. We're finding the details within the story. A 100-ounce jug of liquid laundry detergent can wash 64 loads of laundry. How many loads could a 150-ounce jug of detergent wash? So, first sentence mentions a 100-ounce jug and washing 64 loads of laundry. If I want to set that up, we have 100 ounces, and the abbreviation for ounces is OZ. So if you may forget that, write it off to the side. And then it also says 64 loads. Where would we put ounces, top or bottom? Where would we put loads, top or bottom? Make sure it's matching. It's got to be equal. If we keep reading, how many loads is our target word? That is telling us exactly what I wanted to hear in the sense of the whole purpose of the story. This entire word problem wants us to figure out the number of loads. So if I don't know it, we will put an X for loads. And just to kind of double check, when we read the number 150, it does say the word ounces to us. And if I'm trying to fill that in, I can take a look. Ounces should be matched up with 150. Go ahead and solve that. Let me know what you get. If you solved it correctly, you should have done 100 times X. That's 100X. And then you would have done 64 times 150. That would have been 9,600. To get both sides to reduce and to get rid of the 100, we would divide by 100. That lets this cancel, gives us 8. And 9,600 divided by 100 is 96. If I look back at what X was next to loads. So we would call this 96 loads. Okay? So last question, number 4. It says it takes 1 1/4 cups of milk to make 8 pancakes. How many cups of milk are needed to make 20 pancakes? Again, we have a proportion here. If it gives you a relationship and then it wants you to repeat the relationship in a bigger or smaller way, they are giving you a proportion story. They're trying to figure out, this is what it used to be. I want to change it to something else, but I still want to keep the relationship equal. This happens, as you can tell, with recipes all of the time. Sometimes you might need to make a bigger batch. Sometimes you might need to reduce your batch. It all depends on what the need is. One thing I'm going to point out here is if we're looking at our story, the first sentence gives us 1 1/4 cups of milk, and that can help us make 8 pancakes. I don't know about you, but that 1 1/4 is going to look really gross on top of our fraction that we already have a fraction on. So when we practice this, we took out our calculators back in school, and we would take the fraction part, because remember this means to divide. We'd put 1 divided by 4. That gives us out 0.25. So I can rewrite this as 1, and instead of saying 1/4, I can write its decimal, 0.25. This is the one I want to use, 1.25 cups. And the reasoning for that is it's a lot easier to see and look at than it is to see a fraction on top of a fraction, okay? 1 1/4 or 1.25 cups of milk makes 8 pancakes. I want to, according to this, make 20 pancakes. Would I put 20 on top or on bottom? Well, if pancakes is on the bottom, we're going to repeat that and put it on the bottom over here. So we know that X is going on top, but what are the units of X? What is it that we're trying to find? You should have said how many cups of milk. So we can put cups. Go ahead and solve this proportion. In order to solve it, you will be taking 8 times X and 1.25 times 20. Be careful when you're typing this into your calculator. Make sure you're double checking where you put the decimal. When I go and divide both sides by 8, I get out X equals 3.125 cups of milk. And there's our answer for question number 4. Proportion word problems.